In this video, I'm going over our practice with rational functions and with the graphs of those rational functions. In the first example, you're given the graph and the equation, but we're going back to all of these characteristics of our rational function. For example, I could visually look at this graph here, and I could see that I have two asymptotes. I have my vertical, so I have my up and down, right? So right here, I notice that my graph in this section is getting closer and closer, but never reaching this asymptote, which is at x is equal to 0. I also see that my graph on both sides is approaching but never reaching this asymptote. So notice how on this side here, it's getting closer and closer, closer and closer, never reaching. And notice how we're crossing the y-axis now. So this is our horizontal asymptote at y is equal to 1. Now we can't necessarily see the holes, so we'll have to calculate that. But I do notice that I have two zeros. I have a 0 here at -1 or -1, 0, and one here at 1, 0. So we do have two zeros, -1, 0 and 1, 0. So when we're looking at the domain and range, remember the domain is your x values and the range is your y values. So if I have my domain, we're talking about what are the x values where the graph does exist, or we could say where it doesn't exist. So in order to do that, though, we need to make sure to identify if we have a hole or not. So I'm going to go back and actually factor and calculate. So notice how here in our, sorry about that, in our numerator, I have a difference of two perfect squares. So when after I can factor that because it's x squared minus 1, that factors into x plus 1 times x minus 1. Square root of 1 is 1. Over, well, I can't really factor x squared, so I'm going to leave it x squared. Notice how, do we have any common factors in the numerator or denominator? No, there's nothing that can be canceled out, which means there is no hole. So now let's go back to the domain and the range. So the domain is not necessarily, though, all reals. We do have an exception because remember, this graph is approaching, but never reaching this x value here of 0. So this is the only x value where the graph doesn't exist. So the domain is all reals except 0. And so now looking at our range, notice how this one's a little different because our range actually, if you notice the graph, on both sides never goes above our horizontal asymptote at y is equal to 1. So we can't necessarily state that this is all reals because there's nothing here, no graph, right? No section of our graph, no values above that y is equal to 1. Notice how it's all less than. So that means our y values are all less than 1. So this is our range here for this graph. Now the end behavior, again, same as before. As x's are approaching positive infinity, so as we're going to the right towards all positive, what direction or what is the end approaching? Well, it's not going all the way up to positive infinity, right? It's going up, approaching 1. Same thing for our x, as the x is approaching negative infinity. So now as we're going to the left, notice how the end, again, it's not going all the way up, right? Because it's approaching the horizontal asymptote of 1. So I wouldn't necessarily, I mean, you could go ahead if you hadn't already done this, but pause it, try this, and let's see what you can at least get with identifying. And here we go. So there are actually two vertical asymptotes. So notice how the graph is approaching this vertical asymptote here at -3. So x is equal to -3. And it's also approaching but never reaching right here at x is equal to 4. We also have a horizontal asymptote. So notice how here we do have a horizontal asymptote at y is equal to 2. Then the zeros, well, there are 2 zeros here at -1 and here at +2. So our zeros are both -1, 0 and 2, 0. Now, before I continue with the domain and range, I'm going to go ahead and let's see how we calculate to get the hole, to see if there's a hole in our graph. Well, I notice when factoring, you actually have an a greater than 1, you have 2. There is a GCF of 2. So you can take out 2 here, factor out that 2, and you're left with x squared minus x, 2 divided by 2 is 1, and minus 2. -4 divided by 2, -2. Now, I could still continue factoring this for my numerator. So this is 2 times x minus 2 times x plus 1. Then the denominator. Here we have a trinomial. So I could factor that. Well, what factors multiply to get -12? So focus on factors of 12, but negative and add to get -1. -4 and +3. So here now, do we have any factors that cancel out? No. So again, what does that mean about our hole? There is no hole. So there is no common factor, so no hole. Now, I didn't do this with the previous one, but notice how also our visual, everything matches. Because remember, we always got the zeros from the numerator. And remember, we're always setting those factors equal to 0. So that's why the 2 just goes away, because 2 will never equal 0. But if I've got x minus 2 is equal to 0, that's why we have +2 here for 1, 0. And x plus 1 is equal to 0, making that -1. Same thing here. We always got the vertical asymptote from the denominator. Notice how x minus 4 is equal to 0, so x is equal to +4. And x plus 3 is equal to 0, so x is equal to -3. Also, remember our horizontal asymptote, you always, with the degrees were the same, take the coefficient. So this is 2 over 1, which is 2. So notice how even with our calculations, everything matches. So now let's go to our domain and range. Now notice how the domain is again continuing on and on, right? So it's continuing here. So we have all reals except for we do have those asymptotes again, right? So approaching but never reaching, -3 and 4. Now our range is constantly above and below. Again, it's separated here by, so it's all reals except for 2, the asymptote. Now our end behavior. As x's are approaching positive infinity, so as our x's are going to the right, so continuing on into positive infinity, our end is approaching but never reaching this horizontal asymptote, which is now at 2. Then as x's are approaching negative infinity, as we're going to the left, so as our end here is approaching, again, it's approaching but never reaching 2. So with the next section, you're identifying the characteristics of the rational function. Well, here I notice now we do have a common factor of x plus 2, which means now we do have a hole. So here, remember, everything is equal to 0 when we're setting this up and identifying our parts. That's why the x coordinate of our hole is -2. Then just like before, we would cancel out and simplify, and now I'm left with x minus 4 over x minus 1. This is now where I get my 0 from my numerator and vertical asymptote from my denominator. Remember, everything's still equal to 0. That's why here the 0 is not -4 because that's x minus 4 is equal to 0. So it's +4 or 4, 0. Then the vertical asymptote, therefore, is x is equal to +1. Now, going back to our equation, this was technically a quadratic because if I wanted to go back and oh, wait, sorry about that. Before I do the horizontal, I realized we didn't finish our whole. How do we finish our whole? Well, again, if I want the y coordinate, I know that x is -2. So what do I plug back in for x? -2. So -2 minus 4 over -2 minus 1, which is -6 over -3, making that +2. Now let's go back to identify our horizontal asymptote. Here, this is in our numerator. If you were to do box method, you would see that this is x squared minus 2x minus 8 over x squared plus x minus 2. So notice how they both have the same degree. They're both quadratic because we're doing box method. That means with both having the same degree, we would just take the coefficients. So this is 1 over 1, making our horizontal asymptote y is equal to 1. So with the next one here, this is you're having to factor the numerator and denominator. So if you didn't do this yet, go ahead and pause the video and try this on your own. And here we go. Notice how here, when you factor the two factors that multiply to get 15 or negative and add to get 2, +5 and -3. Then here in the denominator, factors that multiply to get 4 but add to get 5, 4 and 1. So do we have any common factors that we can cancel out? No. So what does that mean? That there is no whole. There is none. That means there are 2 zeros from our numerator and 2 zeros from the vertical asymptote. Again, remember, all setting equal to 0 when identifying our parts. So that means the 2 zeros are -5, so -5, 0, and we also have +3, 0. Then the vertical asymptote, we have two vertical asymptotes. X is equal to -4 and x is equal to -1. Then the horizontal asymptote, y is equal to. Notice how the degree is the same, so take the coefficient. 1 over 1, y is equal to 1. So again, pause the video, try this one, let's see what you get. And here we go. Nothing I can do with the numerator to factor, so I'm just going to have x squared. Now we do have a GCF of 3. So I'm going to take out 3 and I'm left with x squared plus 4x from 12 divided by 3, which is 4, minus 12 from -36 divided by 3, which is -12. Now factor. What two numbers multiply to get 12 or -12 and add to get +4? +6 and -2 here. So now when identifying, again, do we have a common factor to cancel out? No. So there is no whole. Now again, we get our zeros from the numerator and vertical asymptote from the denominator. Remember, all equal to 0. Well, that's just x squared, which is equal to 0, which means our 0 is 0. So our 0 is the origin at 0, 0. Then the vertical asymptote. Well, there are just 2 of them because 3 will never equal 0. So that's why the 3 cancels out that GCF that we got from factoring. But the 2 vertical asymptotes are -6 and +2. Then the horizontal asymptote. Notice how the degrees are the same, so we take the coefficients. Notice how in the numerator we have a coefficient of 1, but in the denominator you had a coefficient of 3. So this horizontal asymptote is 1/3. So now with these, you're writing the equation based on the characteristics. So I like looking at this, again, reading it from left to right and adding as you go. So here, I need an equation where there is a whole at x is equal to positive 2. Well, if you recall, the whole was always the common factor that canceled out. So that means I need in both my numerator and denominator the common factor. Now remember, because it was always equal to 0, we always change the sign. So that's not going to be x plus 2, but x minus 2. So this would represent a whole where x was equal to 2, because then that would cancel out and you're left with the factor of x is equal to 2. Now let's continue. Here I need a vertical asymptote at x is equal to -1. So remember, the vertical asymptote always came from the denominator. So I'm going to go ahead and continue, right? We have our whole at x minus 2 because it's x is equal to 2. Now we have a vertical asymptote at x is equal to -1 from our denominator. And again, factored form equal to 0, we change the sign. So this would be x plus 1. Then the last, we need a 0 at x is equal to 4. So the 0, remember our zeros always came from the numerator. So again, here I have my whole at x is equal to 2, and we have our vertical asymptote at -1. Now that means our 0 was at x is equal to positive 4, making this x minus 4. And this would be the rational expression. Now, if you wanted to also see how this looked as a quadratic, you again do box method, and you would see how this would end up as x squared minus 6x plus 8 over x squared minus x minus 2. Now, we could also tell too, right, that we have a horizontal asymptote at y is equal to 1 because they both ended up being a quadratic from multiplying out box method or FOIL. Go ahead and pause the video and try this one on your own, the B. And here we go. So first off, there's no whole, which means there is no common factor. So we need to keep that in mind. So I'm going to go to the next. Vertical asymptotes. So this came from the denominator. So in our denominator, I need both x is equal to 1, so x minus 1, and x is equal to -5, so x plus 5. Then here we have a horizontal asymptote at y is equal to 2. So this means that the coefficients would be the same, but I need 2 over 1 for my coefficients to make this y is equal to 2. So this was again from the coefficients. So going back to our denominator, well, if I did box method, this would be x squared plus 4x minus 5. So in our denominator, I have x squared plus 4x minus 5, which means I already have a coefficient of 1, which means what do I need a coefficient of in my numerator? 2x squared. And you know what? I'll leave it, because then this could be an example. Now, could there be others? Absolutely. But this shows a horizontal asymptote of 2 with the 2 vertical asymptotes at 1 and -5. With these two, we're going to kind of do a little quick sketch and then check in Desmos. Now, always make sure too, right, if there's the factoring to factor. We're going to identify the characteristics of our graph. Now, for the first one, I'll just make sure you guys are good to go with identifying the characteristics of the graph and drawing in the wholes and asymptotes and zeros, and then we'll go to Desmos to see our direction. So here, notice in our numerator, we have a GCF of 3. So when you take out 3, you are left with x minus 2. -6 divided by 3, -2. So here in my numerator, 3 times x minus 2 in factored form. Then the denominator, you have our trinomial. What two factors multiply to get 3 and add to get 4? 3 and 1. Now, so do we have a whole? No, there is no whole because there's no common factor to cancel out. But we do have our 0 and vertical asymptote here that we can identify. So now notice here that our 0 is, again, remember this is all equal to 0, so that GCF of 3 cancels out. 3 will never equal 0. So our 0 is positive 2, 0. So our 0 is at positive 2. So here's our 0. So our graph has that one solution where it's crossing the x-axis. Then the vertical asymptote, well, there's two vertical asymptotes at x is equal to negative 3 and x is equal to negative 1. So we need two vertical asymptotes here at negative 1 and negative 3. Now, let's go back to identify the horizontal asymptote. We'll notice how we have an exponent of 1 and an exponent of 2. This is less than. So we're not going to do taking the coefficients because they're not the same. They're different. When it's less than, there is no horizontal asymptote. So there is no horizontal where y is equal to a value. So now that I've got my two asymptotes, I've got my 0, there is no whole. So now let's check and make sure. So here's the graph. Well, I notice it's continuing on approaching here. We're crossing here at 2, 0, and it's going above, crossing here. And I notice that it's getting closer and closer, but never reaching not only negative 1, but also negative 3. So all these pieces match. I'm going to go back now and create my quick sketch. So here I've got my quick sketch. Now remember, this will approach but never reach because we only have 1, 0. And then here, then just kind of making that little quick sketch here. Go ahead and pause the video and try the second one on your own. And here we go. So again, you should have factored. So what multiplies to get positive 5? What multiplies to get positive 5 and adds to get 6? 5 and 1. Then in the denominator, what multiplies to get 15 or negative 15 and adds to get 2? 5 and negative 3. Now, notice we do have a common factor of positive 5, x plus 5. So we do have a whole. So with this graph, you do have a whole. The x-coordinate is at negative 5, because again, remember, this is all setting equal to 0 when identifying those parts, those characteristics. We have our x-coordinate for our whole at negative 5. Then I'm going to simplify, cancel out, and you're left with now x plus 1 over x minus 3. So we have 1, 0, and 1 vertical asymptote. We have a 0 at negative 1, 0. So I'm going to go ahead and draw that in, negative 1, 0. We also have a vertical asymptote at x is equal to positive 3. So vertical asymptote at x is equal to 3. Now let's finish getting our whole. How do we get the rest of our whole coordinate? Well, if x is equal to negative 5, that means what do I plug in for x? Negative 5. So negative 5 plus 1 over negative 5 minus 3. So here I've got negative 4 over negative 8, which makes positive 1/2. So that is our whole at negative 5, 1/2. Then the horizontal asymptote. Well, do we have one? Yes, because now the degrees are the same. So we need our coefficients, which is 1 over 1, making this y is equal to 1. So we have a horizontal asymptote at y is equal to 1. So now you could do your quick sketch. Now I notice here, I'm going to continue on with my graph here. Now, there can be no other 0, so I'm going to create my graph here above. And now let's check. And here we go. So again, notice how we have our horizontal asymptote. The graph is approaching but never reaching 1. And we have a vertical. Notice how it's approaching but never reaching here at x is equal to 3. We only have 1, 0 here at -1, 0. Now we can't see the hole, remember, so it's understood that it's going to be right here at -5, 1/2. So that's going to be our hole. Then the last two questions are again now just kind of getting through and practicing. So pause the video and try these two on your own if you haven't. And here we go. So we need to describe the vertical asymptote and hole. So I do need to factor. Factoring the numerator, I do notice I have a difference of 2 perfect squares. So this is x plus 3 times x minus 3. And I have a trinomial in the denominator. The factors that multiply to get 6, but add to get -5, -3, and -2. So now notice how we have a common factor here at -3, which means that was the x-coordinate of the hole. So our hole is at the x-coordinate of not -3, right, but +3. So I noticed from my answer choices, now this one's saying that there were just 2 vertical asymptotes. I'm going to cross that out. But we're saying here, if I notice, that my answer is B. Let's check that the vertical asymptote is also at x is equal to 2. So I'm going to cancel out, and I'm left with x plus 3 over x minus 2. Now, where did we always get the vertical asymptote from? The denominator. So notice how you do end up with x is equal to 2. So that's why B is the answer. Now, question number 2, you were looking for which statement was false. So I'm looking at the answer choices and notice we're talking about all of these characteristics. Horizontal asymptote, the hole, the 0, the vertical asymptote. So I need to factor. Now, I can factor the numerator because notice how they both have an x. So I can factor out a GCF or a common factor of x. So taking one x out, I'm now left with x plus 2. Then over our trinomial here, so what factors multiply to get -6 and add to get -1? -3 and +2. So as I go through and cancel out, well, I notice I do have a hole. So my hole is at -2. The x-coordinate is -2. So this statement here is true. So B is not my answer. Then I would cancel out, and I'm left with x over x minus 3. Now remember, when identifying our characteristics, this is always equal to 0. So here I've got my 0 from my numerator and vertical asymptote from my denominator. The 0 is just x by itself, which means x is equal to 0, or that is the x-coordinate, so our 0 is at 0, 0. So here our 0, that is also true. So C is not my answer. Let's check the vertical asymptote. Vertical asymptote is at x is equal to +3. So notice how this statement is also true. So let's check on this horizontal asymptote. Well, I notice that the degree, the exponents are the same, so I would just take the coefficients. So 1 over 1, which is 1. But why is this statement false then? Why are we saying that this is our answer? Because right here, it said x was equal to 1. Remember, the horizontal asymptote is y is equal to 1. So that's why here the answer is A.